Hello, everyone. Welcome to this live broadcast about El Niño. We're broadcasting today from the Ocean Science Center at the Aquarium of the Pacific in Long Beach, California. Today, we're going to hear the latest El Niño forecast from experts at the National Oceanic and Atmospheric Administration's National Weather Service and NASA's Jet Propulsion Laboratory. As you watch our presentation, you may send your questions to us via Twitter using @AquariumPacific and the hashtag AOP El Niño, or you can send us an email to live@lbaop.org. So we're going to talk about El Niño. The El Niño phenomenon occurs when trade winds, which normally are strong and blow from east to west in the tropics, they relax and sometimes even change direction. In their normal pattern, they pile up warm water across the Pacific in the western Pacific, and under these conditions, you have the water that is moving to the surface to replace the water that is dragged across away from the coast of South America. And this water is nutrient-rich, and it therefore stimulates the growth of small microscopic plants, phytoplankton, and this results in a bloom of small microscopic animals, zooplankton. Little fish come to eat the plankton, big fish come to eat the little fish, and so the fishing is good off the coast of South America. But during an El Niño year, when the trade winds relax or even reverse, this warm water that was piled up in the western Pacific slides back downhill toward the coast of South America. And as it does, this lid of warm water, which is lighter than the underlying water, seals off the deeper ocean so that you don't have this upwelling of nutrient-rich water and the blooms of plankton. And typically then the fishing is poor. El Niño, the name comes from the child in Spanish, or the Christ child. And to tell us more about El Niño forecasts and how meteorologists predict its likelihood, I want to introduce our first speaker. The aquarium has had a long-standing partnership with NOAA and with the National Weather Service, but also with other parts of NOAA. It was through a partnership with them that we created this Science on a Sphere that is to my left, and we have collaborated on a number of experiences, including the one that you're going to see today. Here to discuss El Niño and forecasting for this winter is John Dumas. He's the Science and Operation Officer at NOAA's National Weather Service. John?
Thank you, Dr. Schubel. It's always a pleasure to be here at the aquarium, and especially in this room, because the Science on the Sphere is a fantastic resource, not just to see a movie like we're premiering today that discusses El Niño, but it can show information on it, information about things like ocean temperatures or clouds, or you can track storms. You can really begin to understand how connected the Earth's ocean and atmosphere are. And scientists study those connections. We call some of them teleconnections because we can use them to try and see if something's happening over here, how might it affect us over there days, weeks, even months in advance. One of the most famous of these teleconnections, the one we're talking about today, El Niño. It's kind of an unusual phenomenon, so I'm going to start by telling you what's usual. And the people on the webcast can see a picture coming up of a usual circulation pattern. What normally happens, like you mentioned before, is the winds in the Pacific Ocean will blow from the east to the west. And they relied on them for such a long time, they called them the trade winds, because the sailing ships could conduct trade with them. As he mentioned, as that water piles up on the west side and it's hot and it's deeper down and everything, what happens is the air above it is rising up, and there's a circulation pattern that can go all the way from the western Pacific rising to sinking over by the west coasts of North America. Well, that sinking over by the west coast, that's our normal weather. That gives us nice sunny days in California, and it can make it rainy in Southeast Asia. Okay, well, what happens when unusual things happen? Like he said, those trade winds, they can start to lessen or they can even reverse. And when that happens, the warm ocean waters start moving further to the east. We can track that with things like satellites, ocean buoys, even ships that go out there. And you can see on the sphere behind me, what that is showing is the temperature of the ocean worldwide. Well, what scientists look for is warmer waters making its way from the west across the Pacific to the east, and it goes right along the equator, right along the middle part of the Pacific Ocean. And as we watch that, we also wait to see what the atmosphere does. Is the atmospheric circulation going to change as a result of that warmer water moving from west to east? If it does, what happens is the pattern that you're now seeing on the webinar screen. The convection, the rising of air and making all those storms and everything, now that's happening right around the international date line, much further east in the Pacific. The result of that upward motion there is that the downward motion isn't felt on the west coast of California. So the warmer waters and the absence of that sinking air allow some of the storms that form in the Pacific to find their way to America's west coast, especially here in California. A really strong El Nino, like the one we had back in 1994, they take the temperature in a certain box in the ocean, they average it over a month. And if it's more than half a degree Celsius above normal, it's considered an El Nino. A really strong one has a value of about 2. Okay? To categorize it as an El Nino year, it has to be more than half a degree. Like I said, well, right now, we're 0.8 degrees above normal. So it's a weak El Nino condition. And that condition has to exist for 3 consecutive 3-month periods for the climatologist to say, yeah, we're really in an event. Okay? And that's important because when an event happens, it'll really affect our weather here in California. We've only been studying the effects of La Nina, El Nino since about the 1950s with all of our instruments. And there have only been about 4 really strong ones. But in every one of those years, we had above normal rainfall. Boy, could we use that in California. Drought conditions going on. So some people have said, you know, will the El Nino get us out of the drought? Unfortunately, we've had 3 years of drought conditions, and 1 El Nino won't make up for that. So what is the actual forecast this year? Like I said, the water's there, the temperatures are there, and that's what you can see. Earlier, they were showing a satellite picture. If you look at the satellite picture, you won't see that big band of clouds around where the dateline is. It's still kind of in the western Pacific. There's the line around the equator, but the big portion of it is still more in the western Pacific. So the atmospheric response really hasn't been as strong as we'd like to see. The winds are about normal. So right now, the Climate Prediction Center is calling it a 53% chance of an El Nino and a weak one if there is one. So that's it.
Thank you, John. Appreciate that. And now I want to introduce Dr. Bill Patzert. He's a climatologist at NASA's Jet Propulsion Laboratory, and he's known as Mr. El Nino. I don't know if that's good or bad, Bill.
Well, good morning, everybody. Pleasure to be here at the Aquarium of the Pacific. Now, I have a confession to make. I love El Nino, all right? Why do I love El Nino? We live here in the American Southwest, which is normally dry. 6 out of 10 years are normally below normal rainfall. And when we get a really big El Nino, which is not that often, we can get sometimes normally double our annual rainfall, which here in Los Angeles is about 15 inches. And it can go as high as 30 inches. Now, wouldn't that be sweet? Because we've been in a large-scale, long-term drought here in the American West and the Southwest. Now, why is El Nino so important? You know, I always say the largest single determinant of human civilization is climate change. And one of the big things we see on this planet when we see a change in climate is El Nino, which is a tremendous redistribution of heat in the tropical Pacific, which has a huge impact on the weather delivering and rain delivering jet stream patterns, especially in the northern hemisphere. And so we're always on the outlook for an emerging El Nino. Now, earlier this year, in the early spring, is that we saw a tremendous redistribution of heat in the tropical Pacific. Very, very warm water in the western Pacific, started to move towards the Americas, and it had great promise. And so early on, we were talking about a repeat of the great El Nino of 1997. But as we got into the summer, this great patch of warm water started to disappear. It started to wimp out, and El Nino went into the big fade. And so as we start our rainy season here in November, and by the way, we're late already in terms of rain. Normally, at this time of the year, we should have more than 1.5 inches of rain here in Los Angeles. It's only been about 1/2 inch so far. And so we're at about 35% of normal. So if it's going to rain, it better start pretty soon here. So looking out with this particular El Nino, which, as John mentioned, is going to be a small to moderate event, all right, those are usually not very promising in terms of winter rainfall. And that's really too bad because we do need some drought relief. But, so in terms of El Nino, definitely don't cash in your 401k and invest in umbrellas at this point. But just to give you a little hope is that there are other weather systems here in the American West, and especially in California, that can deliver rain. Great low pressure systems that'll move out of the North Pacific as we get deeper into winter. And so we aren't necessarily going to have another dry winter. So keep your fingers crossed. But remember, it took us many years to get into this drought. The great reservoirs in the West are going dry. The groundwater reservoirs, which are our reserves for water here in Southern California, are definitely way, way down. And so a lot of rain in one winter is not going to be a drought buster. We're going to need many years of above normal rainfall. And hopefully next winter, if we're lucky, we'll get a nice big sweet El Nino. And so you can all join me and hug the El Ninos of the future. Thanks a lot.
Thank you, Bill. Appreciate that. Today we have more information about weather and climate than we've ever had before, thanks to satellite technology, to smart buoys, to forecasting systems and climate models. We monitor sea height and temperature, ocean winds, and cloud patterns. And by using these data, meteorologists and climatologists can help us anticipate an El Nino year, whether it's going to be weak or strong. But you've already heard that this year in Southern California, whether we have an El Nino year or not, we're still going to have concerns about this ongoing drought and water resources. An El Nino, even a wimpy one, would be welcome, but it won't solve the drought problem or our ability to manage it. It took several years to get us into this situation. It'll take several years to get us out of it. I think we need to have a portfolio of strategies that in the short term will reduce demand almost immediately. And while we're doing that, though, we have to be developing longer-term strategies that will increase and stabilize water supply while reducing long-term demand. And with the growing population, that is a challenge, but I think it's one that this state could cope with. Now we're going to take a few questions that have been submitted by our viewers. Allie, do we have any questions?
Yep. Is there a relationship between surf conditions and El Nino? Good for surfers?
Will El Nino be good for surfers? Bill, you're a surfer, I think. Yes. Is it a good for surfers?
Well, I'm an old surfer, all right? But, of course, I've been surfing more than before most of you were born. But the great El Nino years of 82, 83, 97, 98, they're surfing legend because what we had is a series of storms that come out of the Western Pacific and make their way towards California. And so El Nino years have always been great surfing years. I can definitely remember the great surf of 97, 98. Of course, the flip side of that is it does an awful lot of damage along the coast here in Southern California. But surfers love El Ninos.
And maybe as we get older, maybe more not such a strong El Nino. All right, Allie, do we have another one?
Is the warm water we had this summer in Southern
Is the warm water we had this summer off Southern California linked to a potential El Nino? John?
Okay, you could tell the guy in the tie is not the surfer in the group. Well, we did have a lot of warm water, and a lot of people were thinking, oh, El Nino, but not necessarily. A lot of what we got this summer was actually from the storms. It was a very active tropical cyclone season in the eastern Pacific, and we got a lot of systems coming up from the south bringing warm water with it. So, yeah, there was, like he had talked about at the beginning of summer, we saw some warm water coming, but it was more because of the storm systems and the fact that our normal flow from the northwest, cold, was replaced by a more southerly flow.
Bill, do you want to add anything to that? You never refuse an opportunity.
People got pretty excited. Now, one of the characteristics of El Nino is when the trade winds in the western Pacific relax, all this warm water that's piled up near Asia, the Philippines and Indonesia, it relaxes and these great waves form, what we call Kelvin waves, and make their way across the Pacific from the west to the east. They're great travelers. They actually travel pretty fast. When they hit the coast of South America, they disperse north and south along the coast of North America and South America, what we call a downwelling Kelvin wave. And the result is that the water off from Baja California to Washington was unusually warm and unusually deep. And if that had continued, we saw exactly the same thing, by the way, in the summer of '97 or the summer of '92. So when you see these tropical fish, local fishermen were catching fish that you normally catch 500 or 1,000 miles farther south or offshore, everybody got pretty excited. But that did not persist. But it was definitely a preview of a potential El Nino that unfortunately kind of fizzled.
Allie, do we have another one?
Can you explain La Nina and how it is connected to El Nino?
Can you explain La Nina and how it's related to El Nino? Who would like to do that? John, you want to start with that, and then we'll let Bill add to it.
Sure. If you think of El Nino compared to normal as a pendulum swinging one way, the other direction would be La Nina. In La Nina, the winds are actually stronger and the systems can carry further to the west in the Pacific. So the result here in California is we'll have even less precipitation than normal, and it can be warmer than normal, but it can really turn into a soaker in the Southeast Asia.
Bill, do you want to add anything to that? So we have the little boy and the little girl here.
Exactly. El Nino gets its name, the little boy, because it usually shows off the coast of South America, Ecuador, and Peru around Christmas time. And so Peruvian fishermen in the 17th century named it El Nino for the Christ child. But the El Nino is the appearance of very warm water off the Americas. But following an El Nino, the trade winds come back with a vengeance, very strong, and they start pushing all that water back into the western Pacific. And so you get very, very cold water off South America. The anchovy fishery comes back. You get heavy rainfall in Southeast Asia and northern Australia. And for us here in Southern California, La Nina, the flip side of El Nino, normally means the D word, drought, all right? So whereas El Nino usually means it's wet in the American West, Southwest, and even into the American Southeast, a big La Nina following a big El Nino usually means at least a year and maybe 2 years of drought. And so they literally are the flip side of each other.
Next one.
If we have an El Nino, what will happen to global fishing? What will be the impact on global fisheries?
If we have an El Nino, what will be the impact on global fisheries? Bill, do you want to start with that?
One of the biggest impacts on El Nino, the world's largest fishery, that means where they farm fish, harvest fish off the coast, is off the coast of Ecuador and Peru and northern Chile. It's a great anchovy fishery. And literally 50% of all the biomass that's taken out of the ocean is taken out of that fishery. But when it is blanketed by very warm water during an El Nino, all those anchovies disappear. They move farther offshore and farther south. So it has a fantastic impact economically on those coastal fisheries in Ecuador and Peru. And by the way, most of those anchovies are used for animal feed in Europe and North America. And so it rearranges world economics just through that single fishery.
John, I want to just clarify something. Bill, you said farm fish. These are wild capture fisheries, not farm grown. They're wild capture. John, you want to add anything to that?
Well, just the fact that with an El Nino here on the west coast of the United States, we might be seeing some extra storms, so, you know, rougher than normal conditions out there for the people that are going out to do the catch, potentially. But as he talked about earlier, you get some different fish in different locations. And we want to hit the fact that this isn't just something that happens to Southern California. We think about ourselves a lot here in Southern California, but this is a global event. The impacts of this literally around the world, and each of them are affected a little bit differently. What's good in California might be bad off the coast of South Africa, for instance.
And I would just add to that, when with El Ninos, La Ninas, or any kind of climate change patterns, we will see changes in the distributions of where some of the major fish stocks are, because they go where the food is, and the phytoplankton production is certainly an influence of climate and weather. Is that our last question?
Just one more clarification on how El Nino starts.
Okay, one more clarification, how El Nino starts. Who wants to do that? John, go ahead.
Well, here's a great thing for me to try and motivate all of the people who are watching to get into science, because why exactly it starts, we don't know. We measure the effects of it, and we can see things like cloudiness and sea surface temperature, and we can see it happening, but the actual cause is a little bit uncertain. We talked earlier about, you know, redistributing ocean energy. The whole climate system and weather system are really just an attempt to keep the Earth's energy in balance. Hot and cold like to spread out and even out. So what it is that triggers it to begin with, we're not sure, and it's a great study subject for people and future scientists.
Bill, would you like to add anything to that, Bill?
Well, thinking of it at its largest level is that when you look at the planet, we're a solar heated planet. The tropics tend to gather more heat over the year, whereas the poles tend to lose heat. And so in a simple way, the role of the ocean in the atmosphere is to take the excess heat from the tropics and move it towards the poles, all right? Now, sometimes to make a larger adjustment, if you have too much heat gathering in the tropics, for instance, in the Western Pacific, you'll get a tremendous release of energy, a relaxation in the trade winds. And that will trigger what we see is what we call an El Nino. Very, very warm water or heat will move from the Western Pacific into the Eastern Pacific. And that's a long distance. That's a third of the circumference of the planet, all right? And essentially what it's doing is redistributing heat on the planet, trying to make this balance. And so, because if the ocean and the atmosphere didn't do this balance, clearly the tropics get warmer, the poles would get cooler. And so on the largest scale, El Nino, La Nina is just redistributing the heat on the planet so that the planet doesn't warm up. And so the other thing about El Nino, you know, it's a great event in the atmosphere. It really changes rainfall and temperature patterns all over the planet. It also has a tremendous impact on fisheries, which we mentioned earlier. And of course, it has a great, because of rainfall and temperature distributions, it has a tremendous impact on the economies of countries in every continent: Africa, South America, North America, all over Southeast Asia, has an impact on the monsoon, where 2/3 of the world population lives under the monsoon. And so the impact of the El Nino is global. It has huge economic impacts. and it has a huge impact on marine ecosystems. And so, you know, El Nino often gets a bad rap, but the El Nino will give in some continents and take away in other continents. But it's a dramatic event all over the planet.
Thank you, Bill. I want to thank our viewers for sending in those questions. We will be debuting a new bilingual version of what you're going to see this Saturday at our annual NOAA and Our Planet Day. And after the debut on Saturday, it will be uploaded to the network of 110 of these Science on a Sphere facilities across the world. And I want to thank John and Dumas and Bill Patzert. And that concludes our live broadcast. The video of this webcast will be archived on the Aquarium's website at aquariumofpacific.org.